There's another related rates problem. Hopefully you can read this, but I'll read it to you. A toy rocket blasts off from a launch pad with a constant speed of 30 feet per second. How fast is the distance from me, standing here, to the rocket increasing after 10 seconds if I'm standing 400 feet from the launch pad? And the launch pad and me are at the same height, so you don't have to worry about height difference. So we're asking, how fast is this distance changing? Well, I'm going to call it S because it is changing. So I want to know what ds dt is. And I know that this distance, which I'm going to call h, the height of the rocket, I know that dh dt is changing at 30 feet per second. So then we write an equation relating those things. And again, it's a Pythagorean theorem sort of deal. I've got 400 squared plus h squared is equal to s squared. I take the derivative of both sides. I get 2h times dh dt. Right, because the derivative of 400 squared is 0. I get 2s times ds dt. And then I start plugging in what I know. And I cancel the 2's, right? So I'm not actually told how high the rocket is. I'm just told it's been going for 10 seconds. Well, if it's going at 30 feet per second, 10 seconds later it should be 300 feet high. So I'm going to have h is 300 feet. dh dt is 30 feet per second. S is, well, again, if this is 400 and this is 300, we can find S by using the Pythagorean theorem. It's going to be 500 because we've got a 3, 4, 5, or a 300, 400, 500 right triangle. So it's 500 feet, and then ds dt. So solving for ds dt, I've got 300 times 30 divided by 500, and it's going to be feet per second is ds dt, and then canceling some zeros, 0, 0, 0, 0, I get 3 times 30 is 90 divided by, I can cancel it, 30 divided by 5 is 6, 3 times 6 is 18 feet per second is ds dt. So that's how fast the rocket is moving away from me at that moment, 18 feet per second. Let's look at a follow-up question. How fast is the angle of elevation changing from me, angle of elevation from me to the rocket changing in the same moment? So now, we still have the same dh dt is 30 feet per second. We don't really care what ds dt is. We want to know what d theta dt is, right? How fast is this angle increasing, right? Because it is getting bigger as the rocket goes up. So to figure this out, I need to know how to relate how to relate h and theta. And the correct trig function, well, there's two correct answers. There's either tangent or cotangent. Because I want to use a trig function that has h and preferably not s, right? I want as few variables as possible. So I'm going to say tangent of theta is h over 400. And I can either take the derivative of both sides right now, right? Derivative h over 400 is 1 over 400 times dh dt. Or I could first multiply both sides by 400. So I don't even have to think about using a quotient rule. Not that you don't have to use the quotient rule, right? The derivative of h over 400 is just 1 over 400 times h in this derivative. But here you can say, okay, the derivative of 400 tangent theta is 400 times the derivative tangent of theta is secant squared theta times d theta dt. And we have to plug, right, the derivative tangent of some stuff is secant squared of the stuff times the derivative of the stuff. And the derivative of h is dh dt. And then we plug in what we know. So, okay, dh dt I know is 30. So let's go over here. Yeah. Sorry, so I have 400 times secant squared. So if I look at theta, I'm in the same moment, right, where h is 300 because it's been 10 seconds later, and this is 500. So tangent, well, not tangent, secant, I know cosine. Cosine is adjacent over hypotenuse. So cosine is 400 over 500, which is 4 over 5. So cosine theta is 4 over 5 at the moment we're looking at, which means secant theta is 5 over 4. So I have 400 times secant squared theta, so 5 over 4 squared times d theta dt equals dh dt, which is 30 feet per second. Now, I should point out, this is 400 feet. This is just a number, right? Trig functions are just ratios. They don't have any units. D theta dt, we'll worry about them, and this is 30 feet per second. So when I divide by 400 and this other number, I'm going to get the feet canceling. So I end up with, let's see, yeah, gross. So d theta dt is going to equal 30 divided by 400 Divided by 5/4 is like multiplied by the reciprocal, so it's going to be times 4, square it, right? This is 25/16, its squared is going to be, or the reciprocal 16/25. And it's blanks per second, and we'll adjust that in a minute. So let's cancel some stuff. 16 has a factor of 4, and then 100 also has a factor of 4, so that's 25, that cancels. So I've got 30 over 25 squared, I can cancel another 5, so that's going to be 6, that's going to be 5. So 6 over 125. So d theta dt is 6 over 125 radians per second. So when you don't have units, or you have a dimension, radians are a dimensionless unit. So whenever you do this kind of thing, where you're finding an angle of elevation changing, it always is going to be measured in radians per unit of time, not degrees. And it's because all the other units cancel out. And it's also because of how radians work, right? Radians are a ratio of arc length divided by radius, and so the units, the feet, cancel out, or whatever the length is. All right, hopefully that helps you guys.